thank everybody for coming in, especially the folks that are here presenting and folks who are here in attendance. This is a hybrid webinar, so this is being broadcast to the world. So there's people out there that'll be chiming in, asking questions, etc. Go to the next slide, Chris. Admin announcements. We always got to start the meeting with the admin announcements. That if there's a hurricane or a tornado or anything that happens like that, they got a door right over here. Go out, take a right. If you forget and take a left, you can actually go out, the front door. So it's one of those deals. The restrooms are out this door to the right, so that's easy. There's food and drinks in the back for the local folks. Water, Cokes, fruit, etc. back there. So help yourself. There's actually some extra water in those coolers back there if you run out. For those who are eating lunch or taking part of the refreshments, $20 back to Dave O'Brien and Billy Mack back there in the corner. So those things need to be taken care of. But I mean, obviously this is a free webinar, so we're kind of relying on you to pay your own way. Also, so why are we having this meeting? Well, one of the issues that came up was some of the folks that are part of the Vertical Flight Society said, hey, I don't believe we're doing enough to keep the digital piece of this energized. Is there any way that VFS can start a discussion about digital engineering? And being the kind of the engineering arm of this thing with the science engineers and acquisition folks involved in the community, it made sense for us to go ahead and get something started. So we did that, and we anticipate in the future having some workshops. On the web page, there, for those on the web, there'll be a survey when you log in or log out, and it will ask you questions about what kinds of things you would like to see discussed in the following workshops, kind of gearing toward a complex systems program that we're having in September. So all of that effort going toward that meeting will kind of be cumulative as we approach those things. And hopefully that September meeting, we can have these broader discussions about, how the digital engineering frameworks are being utilized for the aviation enterprise. While I'm talking about that, we do have the September complex systems meeting. We have a call for papers in the back there. We got about 20 or more flyers about the complex system topics that we're looking for. If you're interested in contributing to the complex systems or participating in the complex systems effort, grab one of those flyers and get submitted. Eric's going to be the focal point for the complex systems. So they're at GTRI, so he can answer any questions that you may have about the complex systems program, etc. So if you notice at the back table there, back by Dave O'Brien, there's a whole lot of merch back there. And obviously the Redstone Chapter has our own logo and our merch. So if you would like something like that, I mean, talk to, maybe Billy Mack will give you a deal on a shirt if you're real nice to him. I'm not sure. Yeah. Wait a minute, let me do the math on that. So, and we got mugs and we got pins and we got, remove before flight kind of little tags back there for everybody that wants something like that. Get with Dave and take care of that. The agenda today, we're going to try to maintain the agenda as tightly as possible because we have people that are going to be presenting from afar, okay, on the web. And so it's really important that we keep the slots queued up so that they get in at the right time, and the folks up in DC can make sure everything's synced properly. If you have a phone or thing that buzzes, or anything that makes noise, please silence those now, because this is a live broadcast as well as a tape broadcast. So it's most helpful if we don't have, you know, some buzzes and beeps as a part of the overall taping section. In the survey, we've got some topics in there identified. I mean, it's everything from you know, authoritative source of information to workforce development, those kind of things. But if there's a topic that you would like to see developed or worked on as a part of this overall effort, you know, make sure you annotate those things as a part of the survey that you're working on, because those will help shape the overall program as we progress down the road with those workshops going forward. And the workshops will be more focused. I mean, if you're working on, you know, how to write a mil spec for digital data, that will be a very narrowly focused topic. If you're working on something related to airworthiness, it will be focused on airworthiness and the airworthiness process. So it'll be very important that you contribute and interact at those time frames. So if you're here for this, Radiance has asked us not to wander around, kind of stay in this AO. You know, they've got people here working on various projects and things, and it's important for them to be able to keep folks local so that there's no security issues associated with that. Questions? Anybody got any questions about anything? Billy Mack, you got anything to add?
You covered it all. We're here to start the conversation, right?
Right.
We're trying to see that complex system thing going on here in August.
Yeah. Yeah.
And other than that, if you're not members of VFS, consider joining either in person or.
So for those of you on the web, Bill McCandless just mentioned that this starts the discussion. This meeting is intended to start the discussion. And then of course he's campaigning for membership in the local VFS chapter as well as corporate membership for our program. I don't know if many of you track the local chapter and what we do, but a lot of the efforts that we do are really geared towards scholarships. Those scholarships are to folks that are, you know, going in, you know, local chapter folks that are going into the aerospace business. 6 last year?
Yeah, we were 6, roughly $9,000 with scholarships last year.
Okay, so 6 scholarships rolled up to about $9,000. We also try to interact with the universities too. I mean, we've got outreach programs with Auburn, Alabama, Tennessee, Tuskegee. I mean, you name it, Mississippi State. You know, we even go over to Mississippi State because somebody wants to go over there, Bill. So, but all goodness, we try to support those chapters, and this chapter is a pretty big area. It goes all the way down to Florida and over to beyond Mississippi. So it's a pretty far-reaching area that we have for the chapter. Dave O'Brien, got anything? Kevin Rockberger? Okay. Okay, here's the agenda. Again, we're going to try to stick as close to this as we can. That may cause a few minutes of pauses in between, you know, sessions, or we may have to curtail somebody. You know, we'll tell them, hey, just like they do on the news, hey, we're up against a hard stop. You got 30 seconds. That's always aggravating to me. I'm sure it is to you, but we'll see how it goes. So why are we here? Well, one of the things that is huge, and we've seen this across industry, right, across government, is we are much more reliant upon all the digital things that we do day in and day out. Everything from keeping time to computational fluid dynamics. I mean, it's all about how much computer power do you got? How can you get it across the web? How do you share that data? What kinds of things do you need to do to develop an aircraft, etc. Right? Well, DOD decided that we were not capitalizing the infrastructure to the maximum extent possible. And so as a part of that, they put out in 2018, 2017, 2018, a document that says, okay, here's what we want to do. Digital representations of systems instead of what we had done in the past, which was a lot of analytical or analog and paper documents, right? So how do you make that jump? How do you get past that? So next slide. So they started out with 5 tenets that they wanted to take a look at, the goals. And you can see kind of from the slide here what those are. And this will be incorporated onto some follow-up slides that I stole from the DoD folks. But basically, it's all about getting all the tools necessary into a format so we can share data and be able to interact with the tool sets that we have. A big piece of that is maintaining those records. How do you maintain those records? And you have to maintain them forever. So how long is forever? Well, if you ask Dave Cripps or me, forever was about 8 years ago, 10 years ago for all the Cobra data. Because we moved all the Cobra data from where we saved it in AED over to a building. And then, did we digitize that, Dave? No. So that was forever. That's how long forever is. But it's got to be 40, 50 years, right? Now, if you talk to some FAA folks, I've got a 1960 Tri-Pacer, and if I want to do a modification of that aircraft, they go back to the 1960 specs, standards, qualification metrics for that aircraft to do something different to that aircraft. Not today's standard. Okay, so and if you go way back to the old car stuff, that's even less rigorous, I'll put it that way, than what today's standards are. So, but how do you compile that? How do you keep that? Where's it kept? Who does that? All those kind of things are important for the overall system. The third one is really the big one that they thump all the time is tech moves fast. How do we keep up? How do we keep pace with tech? How do we make sure that gets infused across the industry? And how do we collaborate? How can, and this whole collaboration thing, I'll talk about a little more, especially, and I'm sure Matt Sipe he's got all the answers to all the questions about MOSA. So when you have an open environment where everybody has to participate, how do you exchange that data as freely as possible without compromising the integrity of the data, the IP, the cyber, all those things that are involved with that. And lastly, and I think this is probably the hardest one, the one on the bottom there, is workforce development. And even bigger than that, the culture of our workforce. How do we get the workforce to change from what they've been doing for the last 30 to 40 years? And you say, well, who are that? Trust me, there's some big civil servants out there who've been there for 30 or 40 years and still want to do it that way. I'm sure there's industry partners out there who've got engineers down in the bowels of the company who are the same way. You know, I visited some companies that were doing JMR when we were having a JMR program. I went into the company and there was a drafting board with 2D drawings on the drafting board of their design of the PDR aircraft, right? So that was a wake-up call for me. Is you know, it's one of those deals where I didn't know we still did this, or you know, I threw my eraser shield away a long time ago. So kind of interesting. Okay. Next, I put these websites up here so that you, after this meeting, you can go back and you can take a look. That first one is all about the document that was published in 2018 about digital engineering. Okay. There's a video that goes with that discusses the DoD vision of what digital engineering should be or is all about. And lastly, the presentation that I'm going to steal from some of the DoD folks that gave this presentation several years ago, 2 years ago. It's on that website. So it's not like you can't get to these things. And Jim, let me ask you a question about that. All these presentations are going to be available. Will all these presentations be available?
Yes.
Okay, on the website?
The ones I get, and the ones that I'm allowed to speak to, yeah.
Okay, so if you go to the website afterwards, I mean, you don't have to take pictures of this, you know, this slide, but they'll be on the website for everybody to take a look at. Okay, Chris, can you go to that Ken Zimmerman presentation? Okay, here's why there's an emphasis on digital engineering, because the under decided that the policy was going to be that we're going to do this. We're actually going to go in there. We're going to transform how we do business. We're going to make this a deliberate effort. And you know how these things work. The policy comes out from DOD. It trickles down to the services. It trickles down to the commands. It trickles down to the PEOs. And eventually, you know, we get down to the point of actually execution of the policy to make it a practice. And really, right now, that's the mode we're in. We take this policy, we're in the process of making this whole thing a practice. And how do we modify business practices? How do we modify, you know, procedures, efforts, et cetera, going forward? That's what we're all about here. Next slide. And this was given at a NIST conference. So what is digital engineering and why are we doing it? The biggest things are for when you look at these slides, the biggest things they're taking a look at is how quickly can we capitalize on a development? In other words, turn a product. And what are the efficiencies that are embedded in migrating to the digital environment? You know, what are the payoffs? And if you look at the slide, you can see those 5 goals that they had for digital engineering. Let me grab this. And one of the things that one of the things that is going to be necessary when you take a look at this, digital engineering and this transformation is not just about developing an aircraft. It's about transforming the whole kit and caboodle of how we do business. So that whole process of making the people, processes, the data available and be able to migrate them across tools is very important. And it's a life cycle process. I know the DAU guys are loving this because they can talk about life cycle processes and they can talk about, you know, the phases of the life cycle and all those kind of things. And I think Dave is going to come up and talk to us about tool sets that he's taking a look at. But because it's a life cycle process, obviously early on you have a whole different tool set early on for requirements and budgets and projections than you do in a sustainment tail where you're talking about sustainment and products and, you know, performance in terms of AO or, you know, readiness and those kinds of things. So that broad swath across DoD is what we're actually attempting to change the culture and to change the business practices to get after those kind of things. No small feat. And I don't believe that any one element is going to be the same as any other element. Now I'm going to brag a little bit here about aviation, okay? It seems to me that when things like this occur, it's the aviation community that grasps a hold of these challenges and really gets out in front to be able to accomplish the kinds of things that we're talking about. It was that way with CBN. And I'm sure it's that way with a lot of other processes and products. S&T. When we take a look at the S&T portfolio, aviation had a much more concise and much forward-looking portfolio than maybe some other commodities had. Or at least that's what Rugen told me when he stole all my S&T portfolio. So, not that there's any hard feelings about that or anything. So. Next slide. So as you walk through these processes and you take a look at the kinds of things that are required to participate, you know, the pivot of all that stuff is the authoritative source of truth. Now that has to be a resilient source of truth. It can't be there for this week and be different next week. I mean, obviously there's updates and those kind of things, but you have to have reach back into audit trails, traceability, all those kinds of things as a part of that source of truth. And you can walk around and look at the kinds of things we're talking about. It's everything from requirements to DT data, you know, to sustainment models and methods. Okay. The problem is those models and methods don't exist right now in all those places. So there's a very deliberate effort that has to take place in the acquisition community, in broadly across the Army, to get those models and methods in place and be able to communicate on a common basis. And again, it's a life cycle process. So you've got to have that continuing thread going forward. Now, you take a look at something like CBM. When we looked at CBM, we had to collect a whole lot of data. And we did that as part of our quality deficiency reporting system. We had to collect a whole lot of data to be able to say that it was safe to fly with a certain signal output, right? But it was not only necessary to collect the failure mode. In other words, it cracked here or this happened, you know, the wire broke there, you know. But you had to collect the signal, the a priori signal, just before that occurred, so that we could accumulate enough data to say we have confidence now. And we, you know, the AD's full of a bunch of engineers, or SRD now, right? And so guess what? We had numbers. 22 faults gave us a 95% authority with a 90% route bound, statistically, blah, 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 you know. So you figure all that out and you figure what you have to do to get to those numbers. So creating those models obviously is a big deal. We got to go forward and make that happen. So next. And I'm sure that the FAA, Peter and Dave are going to talk about sources of truth. You know, this is very, very important for the airworthiness process. And if you'll notice that on that little sidebar, when you get your slides at home there's nothing on there that says airworthiness. It talks about accounting, it talks about business processes, it talks about, you know, purchasing, program management. Embedded in there is, for all of us in aviation, we know, the really hard thing, and I think Paul Jonas and I were talking about this morning. Hey, if I look at a new product, the first thing I look at is the functional hazard analysis and the certification methodology. If you don't have a good handle on that, the chances of you developing a satisfactory aviation product are pretty slim. Okay, that source of truth has to reside somewhere in there, be accessible to the right people, be able to take a look at that, be able to use the data as necessary for other models that are out there, and make sure it's managed in accordance with all of the security and IP protection that is going to be mandated as part of that overall program. Who does that? Where's it done? How's it done? We don't know. We haven't decided all that yet. So obviously one of the things that we'll have to take a look at as a part of our overall aviation focus on digital engineering. Next. And this one, the folks went into a great deal of detail about what it is that they wanted for these. And those little cubes that you got up there, those little boxes, talk about fundamentally about what kinds of things are you going to do, and really spoke to the technology advancements that allow you to do these rapid acquisitions and get some of the efficiencies. They really talk about, you know, hey, let machines do things that machines are good at, all that big data analytics and all that stuff. I mean, we can look at data all day and not really break something out of the clutter. A machine can do that relatively quickly and be able to ascertain what's the important data. We're taking a look at everything from virtual reality. And when you talk about virtual reality, I think you have to throw augmented reality in there. So not only for the thing that everybody really kind of looks at these virtual and augmented reality pieces are for, I've seen demos on maintainability, right? And what it shows is I've got my HoloLens or whatever I'm wearing on, and it shows me what bolts, I'm looking at the airplane. It shows me what bolts I got to take off, when the generator's got to come off, what wires I got to unhook, and then all the stuff again. So everything from a electronic technical manual through processes to, put equipment on and off the aircraft. So huge maintenance assistance. Also in simulation, you start talking about a simulator. We did a program called Summit, Synergistic Unmanned Man Intelligent Teaming. And the first thing my team in the S&T side went out and did was they created a cockpit. And I said, why'd you do that? And their answer was, well, you got to have a cockpit. And my answer was, go to Sears and buy a great big refrigerator box and put a HoloLens on and put a chair in there with a stick or two. Simulator. Now, obviously, you got to finesse it a little bit, but trying to break the mold away from classically the way we've done it to the new tool sets or the new capabilities is part and parcel to this. It's that cultural change. How do you change culture? How do you get past some of those kind of things? You get on down there, I mean, there's a lot of things on there, but I mean, when we start talking about digital tools in aviation, we're talking about computational fluid dynamics, computational structural dynamics, potential solutions like an RCAS solution set, those kind of things, Nastran models, all the way down to the details of what it takes to develop an aircraft and to prove all those FHA issues that we talked about, Paul talked about with me this morning. So all of those things have to be inclusive in this paradigm. Not just the easy things, but all of those things. When we did some upgrades to NDARC, right? That's the conceptual models that we use to look at configurations for different aircraft. It's a NASA code. And so we took a look at that NASA code and we said, what kind of enhancements do we need to make? Well, the first thing that we wanted to do was go in and improve the CFD capability so that we could turn a model in less than 15 minutes using CFD data. Okay, that's orders of magnitude faster than we did it 10 years ago, a lot faster than we do it today. Well, just as soon as you get the CFD code, and we worked on Helios for those of you who know the code, but there are other codes out there, Fun 3D, Overflow, all the ones that have to be inclusive, or do they? I mean, that's part of the thing that you're going to have to decide as a part of these workshops. What tools are going to be the standard tools that we're going to utilize for requesting digital data? Or do we limit the tools and we just request a format or a product output? So that's going to be all part of that discussion about how do we get there from here. So you see on the end there, digital twin and digital manufacturing. We did JMR. We were able to do some of those replacement parts. We were able to put from the computer model to the manufactured component, tens of thousands, 10,000s, less than 10,000s of tolerance. Now that's really unheard of looking at old tech, right? The new tech, that's a significant improvement over the way that we did manufacturing. Okay, next chart. Obviously, when you do all these things, you got to be able to talk to everybody, and everybody's got to share the data. And then you get into cyber issues and the IP security issues and all those kind of things. Not to mention the fact that you got to do this through other tools, Innovia, Cameo, whatever tool set you're using that as a part of that. So all of those things, your workforce, and next chart's all about workforce, but the workforce has to understand that. They have to be able to utilize those. We have to have an infrastructure set up so that we can do that. As the Comanche chief engineer on that program, we tried doing something like this and we never could break the code on how to get past all the firewalls. Never could. We tried, or at least the government tried. Very deliberately to do that. Okay, next chart. It's about the people. And how do we get people who have a mindset to use the digital environment, who have a vision of where we need to go in the digital environment, who have the training to operate the tools and the products that are relevant to the digital environment, policies and procedures that allow us to do that. You know, I mentioned mil specs for a digital output. You know, right now we're still asking for paper or asking for, you know, digits on a, maybe on a, in a document, but fundamentally the old way we used to do it. So that's really the DoD vision. We're migrating from left to right. We're making that happen. How best to get there? How best to capitalize or to leverage the digital environments that we've created? We've spent lots of money on these digital infrastructures and digital tools. So how can we best take advantage of that going forward?